All right, in this video I'm going to be looking at graphing rational functions. So this is going to be first of several videos on graphing rational functions. So I'm really going to be focusing on the basics in this. So kind of get that foundation, and then the videos after this will kind of build on the knowledge that I talk about in this video. So graphing rational functions, here is our function. This is the most basic rational function we're going to have. Y equals 1 divided by x. Now, we're going to graph this, and there's a lot of things we're going to talk about. We're going to talk about asymptotes, domain, and range, and I'll get to those in a second. So what we can actually do is to try and get ourselves a good idea is start with, you can look at the graph of this in a calculator. So if you graph y equals 1 divided by x, that is what the graph looks like. Now it's hard to tell, but there is our curve down here and it goes down, and then the other curve is up here and goes to the right. So kind of one of the first things I want to talk about before I take this and graph it on my paper is the graph is kind of centered at a point. Now it's not called a vertex. I honestly don't know the mathematical term for it, but in the most basic fashion, it is centered. The entire graph is centered around this center point, which starts at 0, 0. And what you're going to find in subsequent videos is this center point 0, 0 is going to change the more we do to our function. So this is the most basic. As we add more pieces, this center point is going to change. So what's going to happen is that center point is going to divide up our graph. Our graph can be in, there's 4 different options it can be in. What this center point is going to form is it's going to be the center or the crosshair of our asymptotes. So here's what I'm going to do. And when you're graphing these, it's very nice to have a highlighter. So I'm going to make a crosshair. So just a perfect T crisscross through that center point. Now in this video, a lot of this doesn't really make sense. In the future, you'll kind of see, oh, all right, now I see what the importance of that. So our graph is centered at this point, currently at 0, 0 in the most basic fashion, and later on it's going to transform. And what those yellow lines are, the crosshair there, is our asymptotes. This is what our graph in an asymptote is, what your graph is going to approach, but in this case, it's never going to cross. So you're going to figure out that our graph is going to get very, very, very close to this yellow highlighted line, but it'll never cross it. In other parts of mathematics, we can actually cross the asymptotes. We're just not going to see it here in Algebra 2. So my asymptotes, they're going to be 2 lines there. It says x equals and a y equals line. Now the easiest way to come up with those asymptotes is we're just writing the equation of these lines. So we're writing the equation of this vertical line and the horizontal line. The easiest way to come up with it is tell me the coordinates of that center point. So the coordinates are 0, 0, so the x is 0, and the y is 0. So my asymptotes is x equals 0, which is this vertical line, and y equals 0, which is that horizontal line. Now we're going to hold off on asymptotes and come back to that here in a little bit. So my graph here, again, looks like this. So it's actually really, really tight in here, and then turns and comes down. Up here it's really, really tight, turns and goes to the right. So my graph here in the most basic form, now if I want to get super precise, we could do second table and plot all these points, table of values. Notice this x equals 0 point, we get an error. Remember that asymptote, how I said we don't cross it? That's why that error is showing up. So what's going to happen on our graph is we're going to be really, really tight in here, and then we're going to turn and come down to the bottom. So that's kind of hard to see with my hand in the way. We're going like this and turning. So that is a rough sketch of what my graph looks, and it's going to get tighter and tighter on that asymptote as we go on out. So it's going to be in the bottom left and the top right. So we're going to start very, very, very tight, and then it turns because we can't cross the asymptote and goes off to the right. So it's on the most basic graph, we're very, very tight here. Now I want to talk about domain and range. Domain, in the most basic sense, the domain is all the x values that this function can take. So all the x values that we're allowed to plug into this function. So domain is all x values, and an easy way to remember range is all the y values. So the domain is all the x values we can plug in, and the range is the collection of all possible y values we can get from this function. Now, it's pretty easy to look at this graphically. We're looking at, well, what are all the x values? So at -10, I got, my graphs there, -9, or -9, -8, -7, -6. Notice how if I plug in those values, I get a y coordinate, which is between 0 and -1. But it's not until here that all of a sudden, if you plug in x equals 0, what you're going to get is 1 divided by 0. And remember, we cannot divide by 0, so x equals 0 is not allowed. Over here, x equals 5 is allowed because my graph is there. There's a y value associated with all these x's. The easiest way to do domain and range on these functions is pay attention to your asymptotes. Because remember, domain is all the x values, range is all the y values. So domain, what we're going to get is all real numbers except x cannot be 0. So notice how it's just the opposite. So an asymptote is x equals 0, but in my domain, we're not going to allow an x equals 0. I can't plug in 0 here because we're going to get a problem. We can't divide by 0. For range, that's all y values. We're going to get all real numbers except what y values are not allowed. So meaning, what numbers can I plug in here? What values of y do I get? And that's again going to associate with my asymptote. I'm going to get all real numbers except we're going to figure out y cannot be 0. So there is a connection there between my asymptotes. My pen's died. My asymptotes, I can at least point at it, my asymptotes and what restrictions there are on my domain and range. So that is the most basic function that we're going to face. So on these next few, I'm going to move a little bit quicker since now that we have the foundation. So we have y equals -1 divided by x. And what we're going to do is we're going to look at this from a transformation approach, where that number on top is going to be like a in our transformations. Remember, a can flip over the x-axis, and it's going to vertically stretch and shrink. So notice how we get a negative. And whenever we deal with negatives with a, that flipped everything. So we didn't get any movement on my center point. I didn't slide left, slide right. So we're still at that 0, 0 point, which means I still have my vertical and horizontal asymptotes still there. So the point of my center there is still going to be x equals 0, y equals 0. So those are my asymptotes. Remember, asymptotes, that's what we are not going to cross. Our graph will not cross over that asymptote. But here's the deal. Here's what changed. We went from y divided by x to -1, or sorry, 1 divided by x to -1 divided by x. Remember how transformation of a will reflect things over the x-axis. So we were on the bottom left earlier. If I reflected that over the x-axis, I'm now on top. So what's going to happen is I'm nice and snug in here, and we're going to turn and go up. Again, we are not crossing that asymptote. I was on the top right over here, and now I'm going to reflect. I'm going to be on the bottom right. So we're going to be down here. So that was looking at it from a transformation approach. If you didn't believe me, what you could do is you could actually graph it on your calculator and do -1 divided by x, which I typed it in, and oh look, my graphing calculator agrees with my sketch. That's a way to check ourselves. So when I get to the domain and range, we're going to get all real numbers for both, but there are certain numbers that don't work. And those numbers that don't work, again, are my asymptotes. So what is my asymptote for x values? Well, x can't be 0. We're not going to cross x equals 0 here, which is right down the middle. We never cross over. We graph up, and notice how I lift up my pen and then started graphing down here. For range, so all my y values down here, all my y values up there, we never cross this horizontal asymptote there. So all real numbers except y cannot be 0 there. For my final graph, the only other change I'm going to do is now I'm going to have a 4 up top. So I went from 1 to -1, which reflected 4 is going to be stretches and shrinks. For A, stretch and shrink. So that 4 is going to stretch things. I'm going to show you how that works. So since we're stretching, that's not going to change where my center point is. So it's still 0, 0. Still going to have, I'm going to go a little bit quicker on this one. Still going to have my 2 asymptotes. which the coordinates of that center point is x is 0, y is 0. But here's how it's going to change the graph. So I'm not reflected over, so I'm still based on this. Here's how that stretch works. What it's going to do is it's going to stretch and pull things a little bit further away from that center point. We still kind of follow the asymptotes, but everything is stretched and pulled away from that center point. Since nothing else changed there, I didn't slide the center, I'm still going to have all real numbers, and my restriction is always based on my x equals 0 asymptote, so x cannot be 0. My range is going to be all reals, but y cannot be 0. Notice again how these follow my asymptotes. So a quick review, our base graph here centered at 0, 0. When we have a -1, that's going to flip everything, or reflection there, everything flipped. And then when I have a 4 there, that stretch, it pulls everything out. So there's a lot to handle there. It'll all make sense the more examples I do and more videos I do. But this is basics on graphing rational functions.